Hello, welcome back to this video. This is 6-5. We're talking volumes of solids with known cross sections. And what we're going to do is just set up some integrals. We're not going to integrate in these examples. We're just going to set them up about how we would actually integrate if we were going to do that, right? So let's go ahead and look at number 3. On number 3, it says set up an integral for the volume of a solid whose base is bounded by y equals negative x squared plus 2 and y equals x, and whose cross sections are squares perpendicular to the x-axis. So I've gone ahead and already kind of pre-drawn this image, and you don't need the image if you kind of understand what's going on. But here I have this function, y equals negative x squared plus 2, and it's also bounded by this function, y equals x. So here are my two functions, and what I want to do is I want to integrate this region. So what is kind of, if I was to slice this cross section here, which I know it's going to be a square, right? So coming out at us is going to be a square. So, but how do I represent that? Well, remember, calculating area between curves, right, is going to be the top minus the bottom. Right, so if I was to call this S, so I'll just call that side equal to S, that's going to be top minus the bottom. And that's just what the side length of that square is going to be. So what is the top? Well, the top is negative x squared plus 2, and our bottom is x. Okay, so there's our side. So that distance is going to be equal to negative x squared plus 2 minus x. So if I want to set up an integral to go ahead and calculate the volume, it's going to be cross-section's a square, right? So that's s squared. So negative x squared plus 2 minus x. Okay, and I'm going to square this dx. So that's it, right? But we do need our limits of integration. Notice our functions are intersecting here and here. So how do I find that out? Well, you can do it a couple ways. You can do it graphically with a calculator, but without a calculator, you're just going to set your two functions equal to each other. When is negative x squared plus 2 equal to x? And if we do this, we get x squared plus x minus 2 is equal to 0, giving us x minus 2, x plus 1. Sorry, other way around, x plus 2, x minus 1 equals 0, giving us these limits. So x is equal to negative 2, and x is equal to 1. So negative 2 to 1. And there you have it. There is your integral. Okay? All right, number 4, set up integral for volume of solids whose base is the circle, and whose cross sections are equilateral triangles perpendicular to the y-axis. So now what I have is I have these kind of sides that are perpendicular to the y-axis. So it looks like something like this. Now this distance is going to be x, right? From here to here is x. Okay, so I want to set up an integral. Okay, and I need to know, okay, for an equilateral triangle, what is that area formula? And if you flip back to your notes, it is root 3 over 4 times s squared. So note that this is just x, right? That's not fully s, right? S would be this whole distance, right? So really it is equal to 2 times x. And so we need to go ahead and take our formula, x squared plus y squared equals 1, and we need to solve for x. So x is going to be equal to 1 minus y squared, and then I'll take the square root. So I'm going to go ahead and drop in 2 times the square root of 1 minus x squared, and then we're going to square that quantity. Okay, and notice this is perpendicular with the y-axis, so we are going to integrate with respect to dy. Okay, dy. Now, as far as limits go, this is a circle that has a radius of 1, and you can kind of see that, right? So my limit here is 1 and negative 1. So negative 1 to 1. And there you have it. That's it. Okay. Next example, we are going to go ahead and do this with rectangles. Okay, so that side length is going to be a rectangle, so that's the length, right? So I'm integrating again from -1 to 1, and that side length is 2 times the square root of 1 minus x squared. And I also need to now multiply by the height. So it's not a square, right? So I don't know they're equal, so I can't just square this. But they do tell us that the height are 3 times their base. Okay, so if this is the base, then the height is just going to be 3 times that. 3 times 2 times the square root of 1 minus y squared dy. And I got to go back and make some edits. I think I've been writing x squared. I'm so used to everything being in terms of x. Y squared, not x squared. Okay, and that is the integrals. We're done. All right. Okay, again, cross sections, calculating the volumes of solids with these cross sections, it can be kind of confusing, especially since it's kind of abstract and you have to have a good idea visually what's going on. Check out the Khan Academy videos below, even if it's just to scroll through them and kind of check out what those solids and what those images look like. And I'm going to briefly show you here. I'll make myself small again. Here are some examples of what this looks like, right? So this is a cross section of a semicircle, right? You can kind of see the base in here. And then there's a semicircle, and then here's an equilateral triangle, right? So these triangles are coming up, right? And you can kind of see the base of that region here, okay? All right. Hope you enjoyed the video. Hope you learned something. Catch you next time. Peace.